I will be talking around the VMware as a virtualization feature, as this is one of the top virtualized products used across industry. Other virtualization products also do have more or less same features in line to what VMware do, but I've just taken VMware as a reference for my subsequent slide, specifically in the server virtualization. Okay, coming to first non-key mission critical non-functional requirement is the high availability. How we can achieve high availability using the virtual clusters. Let's say your application do not support clustering, or you do not want to have the application level clustering features because of, let's say, licensing cost or some constraints to it, but you are still looking for the HA solution, then virtualization HA is the right solution for such ask. So if you look at this figure, it depicts 3 physical servers, server 1, server 2, and server 3, and all these servers are part of a single cluster with a single resource pool configured into it, and all these again, all these servers or ESX server are part of the same resource pool. So let's say if any of the hardware goes down or the physical host goes down, in such cases, so all the associated VM which are part of this particular ESX host will automatically get migrated to the other resources or to the other available physical hosts which are part of the same clusters. So that's primarily talk around the VMware high availability. So this primarily happen in very quick time. So it just need a restart of the server. Server will automatically get restarted to the OK node. VMware has again got another features which is part of the VMware HA, which is nothing but the fault tolerance. However, high availability is not synonymous with the fault tolerance, so there are meaningful differences between the two terms. It's essential that you understand the client uptime and data recovery need to determine what you need here. So HA is nothing but a base level protection where your virtual machine will get restarted into the other host when the one of the physical node goes down. Whereas fault tolerance provide a high level of availability, so there will be a seamless migration of the virtual machine into the other host. So that is where I said that it's very key to understand what the business is looking for, because high availability is the HA is one part of the high availability package, and the fault tolerance is other part of the high availability package. This high availability solution is generally best suitable for the application which really do not support out-of-the-box HA solution, for example, Jira. I said that you can probably want to leverage the clustering for non-production environment where single host is actually or two host cluster is actually hosting multiple database servers, and that can give you better return of investment than hosting a physical database servers for your non-production environments. The other key non-functional requirement that I'm going to cover is maintainability. So VMware has a very good feature called as DRS and VMotion, through which we can basically maintain our systems or can do the regular maintenance without any outages on the systems. So in traditional infrastructure, there was always been a challenge to IT in terms of minimizing the overall downtime during any maintenance activities. So with VMotion feature in place, no downtime is required during maintenance activity. VM can seamlessly move from one server to other servers using VMotion features in a cluster, and hence servers can be taken out for maintenance. DRS is nothing but a distributed resource scheduling, so that determines the best possible distribution of virtual machines among different physical servers and automatically migrate virtual machines to the most appropriate physical servers in the case there is a physical resource crunch on the servers. For example, if you look at this figure where the server 2 where the CPU is actually reaching out to 100%. So DRS will actually invoke automatically as per the threshold that has been mentioned, and some of the virtual machine will automatically get migrated to other of the hardware or the ASIC server which is being less utilized. DRS along with the distributed power management can also help in bringing up the efficiency of the systems. So during maintenance, what you can do is that, let's say if you really want to upgrade your hardware, what you can do is that you can basically migrate all the virtual machines from one of the hardware which you really want to repair or which you really want to upgrade to rest of the hardware which are part of the clusters. DRS purely work on the VMotion. VMotion is nothing but a live migration of virtual machine from one host to other. So VMotion is the underlying technology that basically helps or enable the DRS to work properly. Scalability. So it has been a pain to create a new virtual machine with the right software installed and configured properly. In fact, we used to leverage tool like Kickstart to automatically install the operating system, and then over to it we generally used to install the other software as and when needed. But configuring such environment is not trivial, and it takes long time from start to finish. And as the virtualization is moving ahead, a lot of virtual machines are being provisioned, decommissioned on day-to-day basis. So going with the older approach of doing the installation one by one is a gone method. So that is where with virtualization, a lot of virtual machines are being provisioned and decommissioned. The other side of it is that the virtualization brings a feature called template cloning, which offers an e-solution in terms of creating a virtual machines. You can pick and configure every piece of software that you need into the template and clone it to a new instance whenever needed. So it's not only the easier way to do it, but it's very, very fast. Let's say if you really want to set up an environment with same sort of application deployed to it, then this is really a very, very fast method to do so. In terms of the scalability, a single host can deploy as good as 256 virtual machines over to it. Each virtual machines can be scaled to 64 virtual CPUs, and the memory, physical memory, can be that a single virtual machine can support is up to 1 terabyte. So you can probably horizontally scale your virtual machine up to 64 virtual CPU and 1 terabyte of RAM into a single physical ESX host. So that is how much you can basically scale your virtual machine and hence your infrastructure. Zero time multi-site cluster, stretch cluster. It's more like an active cluster. I think traditionally data center architectures had hard distinction between high availability and disaster recovery. So high availability was considered an automated failover solution within single data center, whereas DR was a manual process for recovering site from the replicated data. But recently data center architects have begun to look a solution that sits between these original directions or original distinctions. So these solutions include the architecture such as stretch cluster, or someone calls it multi-site cluster or metro cluster. So these primarily offers the ability to balance workload between two data centers with no disruptive workloads, enabling the migration of the services or the virtual machines across both the data center without any outages. But there are certain limitations to it that if you really want to set up a metro cluster or active-active cluster, leveraging both the data centers purely in active-active mode, you need to ensure that both the data centers should be in range of 100 kilometers